Hey everyone, and once again we're back together, just meeting to discuss that November 2021 paper. We've started on it on question 1 and question 2, and now we're on to question 3, which is also based on organic chemistry. So if you haven't subscribed, welcome to our channel and just become part of the family, okay? For those of you who need assistance with mathematics or physical science, you're more than welcome to just get in touch with us, and our email address is info@mlungisinkosi.co.za. Right, so we'll just get straight into it. That's question 3. Okay, they say the melting point and boiling points of 4 straight alkanes, chain alkanes, are shown in the table. Okay, and you can see those are the melting points there, and we've got boiling points, and you can see that as you go down, the chain length is actually increasing. That's pentane with 5 carbons, that's hexane with 6, and up until octane with 8, and you can see that boiling point keeps increasing as well as the melting point. Okay. Right, now let's get into our first question. Right, so our first question says define the term melting point. Okay, and melting point, of course, that's the temperature at which a solid changes into liquid. I'm not sure if that's the formal definition, but I know there is another definition that says the melting point is the temperature at which the solid and the liquid form of a pure substance exist at equilibrium. So I'm not too sure which one would be more acceptable. But you can choose any between the two. Obviously we'll see as time goes, of course, with the formal memorandum. Right, so they say write down the general conclusion that can be made out about the melting points of straight chain alkanes. Now, before I even get to the general conclusion, I want you to note in this case, so this would be a typical example whereby we are given an independent variable and a dependent variable. So if you look at this, what are they changing? They're changing the chain length. Okay, so therefore that becomes our independent variable. Okay, that's what we are changing. But remember, the melting point and the boiling point depends on the chain length. Can you see that? So in that case, that would be the dependent variable. Okay, so always keep that in mind when they give you these kind of questions. All right, so what conclusion can we reach about the melting point? You can see that temperature is increasing there, even though it's negative. Okay, so we can conclude that melting point increases with an increase in chain length. Okay, so that would be our conclusion there. I won't necessarily write those down. Of course, in a way, you will actually just write them for yourself, or of course you understand what I'm saying. Okay, so 3.3, they say name the type of van der Waals forces between molecules of octane. So remember that for molecules of alkanes, okay, you've got what we call London forces. Okay, in that case, those are the weakest form of intermolecular forces that we have. Okay, so those would be London forces. In fact, let me write that down. Okay, so that I'm going to start at 3.3. Of course, we discussed the other ones. Those are London forces. Okay, if I remember, another word for London forces is dispersion forces, right? So you can just also write that as well. Okay, so 3.4, they say write down the predominant phase of the following alkanes at minus 100 degrees, okay, Celsius. So they say choose gas, liquid or solid. Now, before I even get to this question, remember what melting point is. It means for pentane, for instance, if it's below minus 130 degrees, okay, it would actually exist as a solid, all right? But then once you pass that 130 degrees, then it starts melting, it becomes a liquid, okay? But in this case, once you exceed 36.1 degrees, then it becomes a gas, okay? So it means between minus 130 and 36.1, it's actually in between. It's a liquid. Below this, it's a solid, and above this, it should be a gas. All right, so that's how you would actually kind of interpret that. So for 3.4.1, for pentane, okay, at minus 100 degrees, so definitely it would fall in between here, okay, between minus 130 and 36.1. So definitely in that case, it would be in liquid form, okay? So that's our answer for 3.4.1. And let's see, what about octane? At minus 100, okay, so remember it melts at at negative 57, so it means below this it's actually a solid, right? So in this case it simply means that at minus 100, which is below minus 57, it would actually be in solid form. So our answer to that is that it's a solid. Okay, right, next question. So they say hexane is now compared to 2.2 dimethyl butane. Okay, so if you note hexane, it's got 6 carbons, but so does 2.2 dimethyl butane. But the only difference now is that this one is now obviously it's got branches in it. Okay, it's got those side chains, isn't it? Okay, so in that case it would be more spherical in shape, whereas this one would be more linear, right? Okay, so they say 3.5.1, is the molecular mass of hexane greater than, lesser than, or equal to that of 2.2 dimethyl butane? Their molecular formula should exactly be the same. It's only their structural formulae that are different. So in that case, for 3.5.1, they are isomers of each other. They are structural isomers of each other. So in this case, it should be equal. Okay. I hope that you are able to follow. And they say give a reason for your answer, because they have the same molecular formula, right? Because they have the same molecular formula. Okay. Of course, you can also say that they have their molecular mass. In fact, I think this one should suffice. Okay, so 3.5.2. Okay, they say, is the boiling point of 2.2 dimethyl butane higher than, lower than, or equal to that of hexane? So remember, because this one is more spherical in shape, 2.2 dimethyl butane, it would have a lower surface area. And remember that intermolecular forces increase with an increase in surface area. So because it's got a lesser surface area, in this case, it would have weaker London forces in that case, because they're not as many in that case. So in that case, it would have a lower boiling point than hexane. So our answer to that should be lower than. And remember, ladies and gents, I'm throwing in this commentary because I don't just want to give answers, but I want to also provide clarity as to why those answers are what they are. Okay, so I hope that you're patient with me as I give you these answers and when I explain a lot, because I want you to grasp, you know, obviously the full information behind what we are doing and not just to answer questions. Okay, now they say, of course, fully explain the answer to 3.5.2. Okay, and I've just said it just now. Okay, so we can say that 2,2 dimethyl butane, okay, has, okay, so 2,2 dimethyl butane is spherical in shape, or you can say that it has a lesser surface area. Okay, spherical, okay, with less surface area. Okay, if you don't mind, please, I'm just going to write it as SA, right? And then hexane is linear, okay, with a greater surface area, okay. So in this case, we remember, and I'm going to write this, in bullet point form. And ladies and gents, I want you to always avoid just writing too much, okay? Because, you know, some of you are under the impression that the more I write, the more the person that's marking is just going to find, you know, the answer in the rubble. No. Actually, the more you write, the more you actually show that you don't understand the concept, okay? Because obviously you are not going straight to the point. So if you write less and be more specific about, you know, the most important things, that's what's required for the exam. Okay, so in this case, we know that intermolecular forces, okay, so I'm just going to abbreviate the intermolecular forces, increase, the strength rather of intermolecular forces increase with an increase in surface area, with increase, okay, that's because I'm lazy to write all of this down, in surface area. Okay, so what do we note? More energy is required to actually, in fact, let me rather say less energy is required. Okay, so less energy is required. Okay, so less energy is required to separate, and please remember, it's not to break the bonds, but it's to separate the molecules, right? So to separate the molecules of 2,2 dimethyl butane. Yeah, you can continue there. To separate the molecules of 2,2 dimethyl butane than that of hexane, and so as a result, it will result in a lower boiling point. Okay, so essentially that is how this cookie crumbles. All right, I hope that you understood that, and obviously for those of you who've already written this exam, I hope that you got that part correctly. All right, so please don't forget to invite even more people, you know, as we continue to review these questions together. For those of you who are in grade 11, or for those of you who are in grade 12, you can actually continue to enjoy these great lessons. Continue to tell others and tell them about this channel that's assisting you quite a lot. All right, and from me for now, I'll see you next time. Sharp, sharp.